Hi guys, I welcome you to my channel. Today I'll be solving a very simple question, not very simple question. It's medium question of Pacific Atlantic water flow. So what is saying that we will have M cross N rectangular island and the border that border both the Pacific Ocean and Atlantic Ocean. The Pacific Ocean touches the island's left and top edges, and the Atlantic Ocean touches the island's right and bottom edges. Okay, so see here, this is the land, and this is the Pacific Ocean, and this is the Atlantic Ocean. So the island is partitioned into the grid of a square cell. You are given an M cross n matrix or integer heights. M cross n matrix integer of heights, where the height of R and C represents the height above the sea level of a certain cell at coordinate R and C. So basically this is one, right? So basically this one is the one height of the sea level, two height of the sea level, three height, five height of sea level, right? So the island receive a lot of rain, and the rainwater can go flow in neighboring cell, directly north, south, east, and west. If neighboring cell height is less than or equal to current cell height, water can flow from the any cell adjacent to ocean and into the ocean. Adjacent to ocean into the ocean. Return 2D list create coordinate result where result of I is equal to R of IC and denotes that rainwater can flow from the cell. See, what is saying that consider this case, we are this land is receiving the water. So uh, what is asking us? So I have to return a 2D list grid coordinates results where result of I is equal to Ri comma Ci, basically coordinate of the coordinate of height, coordinate of a cell denotes that rainwater can flow from Ri to Ci, from RICI to both the Pacific and Atlantic Ocean. So it's saying that consider the case this 5, right? 5 can flow from to the Pacific Ocean as well. From 5 water can flow to the Atlantic Ocean as well. So 5 will be my answer. So what is the coordinate of 5? 0 1 2 and 0 1 2, 2 comma 2 will be my answer. Okay, so we have 2 comma 2. So here see here 5, we have this 5 on the row 0 and column -1 index. So see here this 5 also can flow on the Pacific Ocean and Atlantic Ocean. So it will go right, and see right we have already, or top also we have, and on the right, on the left, sorry, it went left. So it went left and meet the Pacific Ocean. Water went to the right and meet the Atlantic Ocean. So 5 also can be inside the result section. So see, we can solve this using two approach. First will be the, we are going to each cell and trying to check that if that particular cell is basically this particular cells, sorry, we are checking that uh, if the water from that cell is going to the Pacific Ocean or not, or Atlantic Ocean or not. If both are satisfy, if the water from the one is going to Pacific Ocean and water from the one is going to Atlantic Ocean, it means that we have this cell is worth of adding into the result section, right? But here see, one is the one we have, right? So from one the water can go Pacific Ocean, but from one water can't go the Atlantic Ocean. Why? Because we have two which is nearest element of one, which is greater than one. We have three which is greater than one also. So one cannot go to the two, one cannot go to three. So this is what the, so we will not take this to one, will it take two? So we see here on the right it can go to Pacific Ocean. Sorry, in the left it can go to the Pacific Ocean, but on the right it can't go. So it will go to 2, but again we have 3 here, which is greater height than 2, so it can't go. For again this 2 will not go. For 3 it can go to the Pacific, and can it go to the Atlantic? No. For 5, yeah, it can go to Pacific and it can go to the Atlantic. So same here, for 3 it can go to the Pacific here, and can go to Atlantic. Let me check. It will go to the right and we found greater than the 4. It will go to the bottom and we find greater than the 3. So it can't go to the Atlantic, so we will not include this. So this two will also not included because we do not, this is the landlocked. 3 is greater than 2. Okay, it can go to the Pacific but it can't go to the Atlantic. This for 3, this 3 as well, it can go to the Pacific but it can't go to the Atlantic. For this 4, you see here, for this 4, all the element in the left side is smaller than the 4, all the element on the top is also smaller, so you can go this direction or this direction. I have to check either one. If this is true, I will return, right? So this went to the Pacific, and 4, it can go to this direction or this direction as well, so I have to take either one. So for this 4 also, this 4 can go to the, like water from this 4 can go to the Pacific Ocean and Atlantic Ocean. Okay, now for this 4 as well, it can go to the right here, right and left as well, and bottom as well. So in the right, we have Pacific, on the left we have Atlantic. You understood my point, right? So basically what we are trying to do. And one more thing na, ki we, for each direction, consider the case here we have 4 here, right? So consider this, we have 5 here, just to understand this 5 here. Now if we have 4, and the water will try to go to the the left, so this is 3 which is smaller than 4, so water can go here, right? Now from 3, water try to go to the 5, which can't go because greater than this 5, this 5. So from 4, water will go to the top of the Pacific Ocean. So because 3 and 4 is smaller than the 3 and 2 is smaller than the 4, so this in this case we can go. So what is happening, that for each coordinate, for each index, we are going to the 4 direction for each sail, right? And we try to find that if sub sail can go to the both oceans or not, right? If this is the case, we'll add to our result, right? So this is basically, we are trying to iterate every node or every cell of the water. Okay, every cell of the water. So I have tried solving this problem. So for each cell, I'm trying to iterate all possible solution, from each one. If all possible solution, and if we found that all possible solution, we will add into the result. But the time complexity, like is drastically increase. Time complexity will drastically increase, and the time complexity will be the, see here, we are going to the 4 direction, right? 4 direction, and that 4 direction can go to the next 4 direction. So the time complexity will be the 4 to the power, basically. We have m cross n, that is grid, whole grid, right? We have to the m cross n possibility, right? And we are looping, we will loop to the whole grid, so that will be the m cross n, so this is the time complexity for the uh, for the so for the first approach, I'm trying to see, like for each cell we will go to the each and every direction. So this is for, you understand why this is for looping the grid, and this is for basically, we have 4 direction to go, right? Top, left, bottom, right. So for each cell we have 4 possibility, and for each 4 possibility we have again m cross n possibility, right? We are not marking that visited. For each cell we are not marking visited, right? Like for each cell we have previously marked visited, but for that we have m plus n possibility, right? So that is the time complexity when we are going to solve, we are going to take each cell and try to iterate. Another best solution we have, what can we do? We will just we are all like in from the corner, we'll try to start our iteration. So we know that this water will go to the Pacific, obviously. Now I'll try to check that if this one can go to the I'll check that if this water is going to the Pacific, correct? Now I'll check again if this water will go to the Atlantic or not. So this will not go to Atlantic, so we will create a two set for Pacific, for Atlantic. So I said because we do not want to have duplicate value, and we will have that is the case. So I said, so we'll create two set to check for Atlantic, for Pacific, and at the end we will just return the union of, so not union, intersection of both Pacific set and Atlantic set, and the intersection value is the value which are we are looking for, right? So this, from this five we can go to the Pacific. So this will be added into the coordinate will be added into the Pacific set, and for this five we can go to the Atlantic as well. So coordinate will be added to the Atlantic as well. So how it's helping us? So see here, we are getting a set, right? And we are getting a set. So once this, consider the case 2 4 is telling us we'll go for 2. So 2 is, yeah, it can go to the Pacific. Now let's move all the direction. So 6 4 3 and this left. So left there nothing, 6 is already greater than 4. We can go to the 3 because the we are going from ocean to the centermost, or the uh, we are going from ocean to the cell, ocean to that cell, or that height which is sorry, ocean to the max height of the cell, right? So from 2 can go to the Pacific. Now let's see that can it then 3 go to the Pacific. Yeah, we have already 2 that is in the Pacific. So we'll try to check the 3. 3 is not greater than 3 is not as smaller than 2, so obviously it can go, right? So we will add 3 in the Pacific also. Now from 3 we'll try to check all the upward direction, that 1 can't go, right? From 3 we can't go to the this direction. From 3 we can't go to this direction as well because 2 is smaller. So I will return it. So 2 and 3 is added to the Pacific. Now I'll go to the 4 because we have already went to the 6 3, and on the left we'll go to the 4. Okay, we'll go to the 4 and we'll try to check that if we can include into the Pacific or not. So yeah, this 4 is basically greater than 2, 4 is not smaller than 2, so we can include 4 into the Pacific. So we included 4 into Pacific. Now we'll go to the all 4 direction from the 4. So see here, we are see here we have already visited this cell, right? We have already visited this cell, so we are not going to take. Have we visited 2? We are not visited 2, but this 2 is already greater than smaller than 4, so we will not do that. Can we visit this 4? Yes, we can do already. So 7 can be added into the Pacific, and from 7 we'll again go to the all 4 direction. Can we go to 6? No. Can we get to 1? Can we go to this one? No, it can't go anywhere. So 7 will not, so we'll return that. So 2 4 7 is added into the Pacific, and 3 as well. So from here I can go here 5. Can 5 go to the Pacific? So abhi tak till now we have a 4 which can go to the Pacific. If till 4 we have, now we'll go to 5. So if 5 is greater than 4, if 5 is not smaller than 4, right, obviously we can go to the Pacific, right? So we have added to the 5 into the Pacific list. Okay, same way which go to the ocean. So we'll try to check, we'll try to take corner for each cell, each grid, corner, like from this corner and this corner, and check that if this 5 leads to the lead this 5 and all the neighbor of the 5 is like eligible, or is um, what all the 5, this 5 and all the neighbor of the 5, that 6 7, uh, can we go from there to the cell, sorry, to ocean or not? So right, so what we are checking, that all the element which is greater than 5 uh, will be the best choice to add into the set, right? So that's how codes goes. Let me write the code so you code, then you'll understand best. So we will have two variables, rows, all obviously, and calls, and first will be length of the height, and the second will be length of heights of 0. Now we will have two set, Atlantic set, at Atlantic set, and Pacific set. and we will have result that will for the answer. Okay, now what, after all this happening, all this like calculation we do, we at the end what we'll do, we'll look through the grid. So for I I in range, I in range, I in range of rows, and for j in range of calls, and if I comma j in Atlantic set, and I comma j in Pacific set, if both is in the set, we will finding the union, right? I will append this to the solution. So result dot append this I comma j, I comma j, right? I have appended the solution and I will return. So this is the result. So this is the last logic we will be doing, and after that this is the main logic we have. So we have, so what I told you, from each side of the cell we'll try to go and check that if that cell I will from each cell, from the like at the beaches of the ocean, like this 1 3 2 6 5 is the beach, right? So for each cell we'll try to check that if that particular cell is can go to the Pacific, if that particular cell can go to the Atlantic or not, right? And we are keeping the set so that we don't add the duplicates value, right? So we'll try to go, let me write first DFS, and we will have I, and we will j, this is current I, current j, and the current set, and the value, value or previous value we are trying to compare, right? Now what I will check that if this is out of bound, then I'll just return it. If this is out of bound, so I less than 0 or I greater than equal to the rows, or j less than 0 or j greater than equal to the calls, or what, or that particular index, that particular coordinate is not in the current set. So if I comma j not in the set, if that is the current in the set, I will return it. Or I'll check that current value, like heights of I and j is small, is, if it's smaller than the previous value, I will return it. I'll just return it. Okay, I'll just return it. If height of current value is smaller than previous value, I will just return it. Okay, uh, it means that we are not going to check, we are going to out of bound, then we're not going to do, we'll just return. Or if that I comma j in the current set, I comma j in current set, or height of I is less than previous val matlab, mm, we are not going to write, we consider this is 7, and if 4 is smaller than 7, right, there's no need to go, because water will not going to come from 4 to 7, right? So that is the simple answer solution. If this is not true, what we'll do, we'll just append that value into set. So current set dot add that value. So it means that this particular index or this particular coordinate, uh, this particular coordinate is basically a good candidate or good cell to go from this cell to the ocean. Basically from here we can go to the ocean from this cell, right? If this is not true, now we'll do all the 4 direction from here. So we'll take directions. We will go to the top -1 comma 0, we will go to the bottom, that is 1 comma 0, we will go to the left -1 comma 0, sorry 0 comma -1, and go to the right, so 0 comma 1. We have all this we have all this four direction to go. Okay, so now we'll just do this for uh, direction in directions. So I'll check that to go all four directions. So dfs of I plus, let me parse it, r comma c is equal to direction I plus r comma j plus c comma, now this new value we will have. So uh, heights of I comma j is the new value. That's it, we have tried it. Now we will have we'll go from all four corner, right? So we'll go from this cell and this cell first. So I'll write the 4 I in range of what this calls, right? So calls and dfs, so 0 comma I. So we'll increase the column. So 0 column, second one column, 2 column, 3 column, 4 column, comma a value at that column. So value at that catalog coordinate. So HIJ heights of 0 comma I. Same will go for the bottom one. So 0 comma high. Now it is the rows minus 1 at the last one, comma rows minus 1 comma I, right? So we'll check all the possible solution from this to this. Now we'll go to the on the left and right. So for I in range of rows, and we'll copy this and we'll go all possible direction. So that is the, we are increasing the rows, right? So I'll be in the first place, and for the first we are using 0th column, so I comma 0, and second times we are will be go to the last of the column, so cols minus 1 I comma cols minus 1, because is again we are increasing the rows only, but the column will be the fixed. So for the first we'll go zeros column, and last after processing all these columns we'll go to the what this, but basically one by one we have processed this one, now I'll process this one. We have processed 1, now I'll process 5. We have processed 3, now I'll process 4. Process 2, 1. That's why we do. Same I'll update here as well. I and calls minus 1. So this is how I am trying to solve this solution. Now let me verify one more time if I'm doing anything wrong here. So this will update me. Okay, I have added to the current set. Yeah. So the DFS problem is very simple. We'll check that if that particular variable, if that particular value is in the set or not. If this is in the set, I'll just return. I'll not going to add again. So basically this will help me to reduce the time complexity as well. We are like for one cell we are visiting at most one time only. We are not going to visit more than one, right? So that time complexity will be m cross n, right? And space will be m cross n only, because for each cell we are creating new recursion function. So yeah, so at most one times we are visiting, we can't visit more than one because we have already added, and it signifies that this particular cell is capable, this particular cell like water can flow from this particular cell, right? So we have rows, columns, length. Okay, we have said that we're going to store all the value. Okay, and all the value of the water, that all the value of coordinates or cell that can be flow water from him or itself. Now we have result, and we have direction, but where we are going, like for each cell we will go top, left, right, bottom. So this is basically top, and this is called bottom, this is for left, and this is for right. So now we have DFS. This will check that if we have not visited that cell already, or if that cell is out of bound, or if the value we're trying to check is smaller than the previous value. If this is case, we'll just return it. Now I will add the value. If not, if that is not the case, I will add the value to the set, respective sets. Now I'll again go to the all four direction, and here basically we are doing this loop. Yeah, that's it. Probably let me submit it. So test it first. I hope I don't get any bug. I got the bug. Missing one requirement required positional argument. Trivial. Okay, okay. Sorry, I have to get a set. Okay, sorry. So we are 0 to 1. So we are on the left side, right? 0 to I. Basically, we are updated in column. So we are on the top side, right? This one. For the first one, we are here, right? If we are here, I will call the Pacific, because this particular borders touch to the Pacific set, right? So I will add this Pacific set, and here Atlantic set. Row is -1. This one is Atlantic set. And same here, right side of the grid. This is Atlantic set, and this is the Pacific set. Pacific set. Okay, so Pacific set. Now again here DFS we have IJ and current set. Current set. Yeah, this is it. Let me submit it. So it's very interesting question, and I study. I tried to solve it, but I could not understand how to solve this problem. So that's why I could not upload a video. Today I solved it. I understood very well. That's why I solved, and trying to solve you what I have understood from this problem. Very simple problem, very elegant also. So what my first approach was, from cell we trying to go to the ocean. Now from the ocean we are trying to go to the cell. This was the second approach I have done, and it improved the time complexity drastically, right? So what was my first approach? We are trying to go from the cell to the ocean, but here we are trying to go from ocean to the cell, and using this approach from ocean to the cell, the speed increased, right? And time complexity also time complexity became like m cross n, like coordinate or grid size only, and the space is also that. In the last time the complexity was huge. I was able to solve the problem, but time complexity was huge. So if the coordinate is more than 200, we might get TLE. But yeah, so thanks for watching. We'll meet tomorrow again with a new video. Bye bye.